So when I was growing up in the United States to Israeli parents, most of the content, the books, the movies that I received at a pretty young age were in Hebrew. Of course, this was for the purpose of teaching me the language before, the English took over my brain. And Mom, Dad, if you're watching this, thank you because it worked. I now speak a couple languages. Anyway, one tape that I loved a lot as a child was called Hakina Nechama, which in Hebrew means Nechama the louse. Nechama is the name. If you don't know what a louse is, because a bunch of people don't, it's actually the singular form of lice. Those gross things that crawl around your children's heads. I know that's disgusting, but it actually, it told a very cute story about a little pink louse, as you see, whose name was Nechama, who decided that she didn't want to be like every other louse, and she wanted to get out there and see the world. She wanted to travel. She wanted to see other cities and meet other lice. The problem is that obviously nobody liked her and was constantly trying to get rid of her. And so she jumped from head to head, trying to find a home until she accidentally lands on the head of this bald man. And he is so excited to have her because he now has the same problem as people with hair. And he's always wanted to, be one of those people with hair. And they essentially become friends and live happily ever after. Now, this is a ridiculous story that's supposed to teach children about the perils of lice, and you're wondering why I'm telling you this. My name is Avital. I am the Israel developer advocate for Vonage, and when I joined last year and learned about our communications platform and how many messages it handles per day, I suddenly thought of this, of the 1 in a million little notification making its way on this great journey of 5, 10, 15 stops and in just milliseconds, in this case, arriving where it needs to be. And it made me think of this cute little pink louse that I loved as a kid, 1 in millions, who was, who had purpose and ambition and eventually made it to the head of the bald man who wanted her perfect match, precisely where she needed to be. What a miracle, isn't it? But here's the thing, in the world of children's books, it's happily ever after. But in real life, and you know this as engineers who fight bugs for a living, and you know this as speakers who have fallen prey to the demo gods, things don't go as planned. Objects get lost, notifications never make it to their destination. So let's talk about this real life of infrastructure engineering, of tracing our steps and ensuring that we know what's actually going on at every point of the dangerous journey, and making sure we don't get lost, we don't lose the rebels along the way. But first, I'll give you a little context. The Vonage Business Communications Platform, the system I'll talk about today, offers capabilities for voice messaging, video, and voicemail on both desktop and mobile. This platform is home to 150,000 users who, through all those functionalities, produce 800 notifications per second. And the kicker? They happen in 15 milliseconds, because that's the kind of standards that you and I are used to nowadays. So what does this 15 millisecond journey of a cute little notification look like? Well, in order to show you that, I need to start at the very beginning, to when you would log in to the communications platform. This is your laptop. So let's say you're on your computer, you're using the desktop app. Your laptop, through the client, connects to what we call the bus station, because this entire infrastructure that I'm about to show you is called the bus, and this API is the first point where the client of the communication platform can make an introduction. Now the bus, it introduces itself to the bus. It says, "Hi, I'm John's computer, and I would like to sign up for notifications." The bus pings its API, which we called Frizzle because we're clever and the children's book references never end, to tell it about the new connection. All of the identifying information gets stored. Frizzle connects with the message broker and to create a queue for you, if you or use the same one if you have one, and with the help of the message protocol, it determines which queue to put your messages in. The protocol then returns a URL, and thus a WebSocket connection is formed between your client and this entire thing that we call the bus. And then when someone sends a message to you, it hits Frizzle, the API. Frizzle sends the notification to the message broker, which sends it to the WebSocket connection that you have open and makes it to your device. So far, so good, right? Wrong. What about the cell phones, the mobile app? I can't exactly maintain a WebSocket connection with the phone at all times, can I? So what about those push notifications that I promised in the title of my talk? So when you fire up your mobile app, with this platform, with this app, a similar flow happens as before. Your phone introduces itself, connects to the bus station and introduces itself with your ID, information about your device, and something called a push token, which we'll use later. Now, in your app, like in most apps, you've set preferences regarding which notifications you would like to receive. Maybe you want to see calls, but you don't want to see messages. Or maybe you only want to receive direct messages, but you don't want to receive group chat messages. So in that introduction, the app is sending all that information about those settings. The API then handles and stores away this information, and you are now signed up to receive push notifications. And now the part that I left out in the first flow, so as not to confuse you, goes like this. When Frizzle sends a notification to your queue, as we saw before, it actually also sends it in parallel to the HTTP service. This service, a pretty generic HTTP service written by us in Node, knows whether you signed up for push notifications and whether to forward your messages to PushMe. PushMe is another Node service that we wrote. It has a database of push tokens which identify your app, and they're mapped to each user, which tell it which operating system to send to and which device. Now, this is important for you if you are building an iOS app, because ever since iOS 13, we were required to display every single notification that hits the phone. And when I say notification, I don't just mean the body of the message you received. Notifications can be messages, phone calls, invitations to a group video meeting. They can be message delivered. They can be message opened receipts. And you don't want all of that showing up on the user's phone. Now, the way it used to be pre-iOS 13 is that all notifications would arrive to your app, and the app itself would decide whether to display it. But now with this new change, we need to display everything that comes through, and specifically what kind of notification will it show? Like, is it a full screen phone call, or is it just a rectangle with some text? So PushMe, in this case, plays a super crucial role in determining whether to mute that notification, as we call it, meaning not send it at all, or to actually send it to you, and if so, to specify exactly how it will appear on your phone. Great, and so now that we know how the messages get to you, how can we guarantee arrival for 16 million daily notifications? Well, the obvious answer is trace IDs in the logs, ensuring that the same trace ID is always used for that specific notification in each service that notification is going through. But how do we do that while separating business logic from infrastructure? If we've got a trace ID everywhere, we don't want a trace ID showing up all over our code, do we? In this case, a handy NPM package comes to the rescue. And this part is important even if you're not trying to build a massive communications platform. I'm talking about a continuation local storage package, or CLS hooked as it's called, which uses async hooks in order to maintain something like a local storage for each session, for each request session. Now, if you're already using Node 14, though, there's actually an experimental API built in that does just this. It basically allows for the trace ID to be saved in a local storage so that it can be retrieved for any log and any request at any point of the flow. Now, in our case, there are 3 places that we need to worry about tracing: arrival at a service, exiting a service, and logging the various events that happen within that service. And we wanted this to be part of the infrastructure instead of getting tangled in the rest of the logic, as I mentioned before. So if you consider this block of the diagram that we looked at before, and I know we're looking at this a lot, and I hope you like it because I spent a good amount of time on it. If we consider this part, imagine that there's a push notification headed to your phone telling you that you received a message from Piotr. As we saw before, it is cute Mrs. Frizzle who sends the notification as a request to both the message queue that we saw before and the bus HTTP service. Now, upon arrival to the HTTP service, there is a middleware in place that grabs that trace ID, so that's C1D987F if you can't read it, from the headers of the request and places them in the session's local storage. And we'll see what that looks like in the code in a second. And now various logs happen, as different things happen, like a log stating that the notification with this trace ID has arrived, and then another log about the fact that the user is signed up to receive push notifications. So yes, we can send this along. And then another log right before the notification heads out. And now using the middleware, that trace ID is added each time to those logs before they're written. Those aren't the only logs, by the way, there are others. And then, assuming you're accepting push notifications, the interpreter grabs the notification right before it heads to PushMe and tags that trace ID to the headers of the request. And so now let's see what that looks like in our code, which has all been taken from the real production code of the bus HTTP service. First of all, we create an instance of that CLS middleware like this. We're going to be looking at that NS in a second, so pay attention to it. And then, firstly, the code that you're seeing here is what intercepts a request when it arrives at the service. The middleware first checks whether the headers have a trace ID. Assuming it just arrived from Frizzle, then it should have a trace ID. If it doesn't, then a new one is created. Once that is taken care of, a few lines below, you'll see the trace ID is set on the CLS namespace. And that saves that ID to its local storage instance. Now, at this point, once we've done that, we can mind our business, right? Doing things, checking the database. We want to know if this guy is signed up to receive push notifications. And for each of these steps, a log is written, and then before it is sealed, it is stopped by the middleware again, which will add the trace ID to the log by taking it from the local storage, which you can see in the NS get and the add tracing to log entry above. And finally, the same interpreter sits on Axios, the HTTP client, right before a request is about to go to another service. We catch that request right before it goes off. We take the trace ID from the local storage and add the trace ID to the header. And all of this ensures that the logger doesn't need to know anything about the trace ID. Now, obviously, CLS is super powerful in this context, but it doesn't only need to be used for logging. You can use this for any situation where you want to kind of like separate the business logic from infrastructure stuff like this. You want to have, user information available at every step of the way along your services, but it is particularly useful in this case for logging and tracing. Because now, when PushMe finally sends that notification to your device, we will have that final log with the trace ID in question, and we know that we sent that notification to the App Store. That way, if a notification was sent to your phone and you didn't get it, we can pretty much blame Apple, because don't we love blaming Apple? Especially when a discussion session is happening on an app that only exists on the Apple Store. That one was pointed at you, Piotr. Anyway, this is what a series of logs looks like for a notification about an inbound call. There are a bunch more, but I didn't want to flood you with logs. So these logs include actions, searches, inbound and outbound requests. If you look at the timestamps, you will notice that it's going from Frizzle to the HTTP service to PushMe in a matter of 4 milliseconds. And so this might not be the heroic journey of a cute little parasite around the world, but hey, for all you know, these could be the notifications. These could be the logs of a little notification that made it around the world in under 15 milliseconds. I would like to thank you for having me this evening. Thank you for inviting me. Thank you to Jonathan for the support. And a very special thank you to Ori Schofman from Vonage, who gave me tons of hours of patience and taught me enough about the bus so that I could give it the representation it deserves. Thank you.
Congratulations, Avital. What a story. Thank you very much.
It was for you.
Thanks so much. You actually also provide workshops on that, and there is one actually free space on the next workshop on 15th of February, right?
There
Because
is, yeah.
I took one, but there is one more. So if someone wants to join us, please write us on Slack on random. And yeah, you had some questions. Yeah, one of them is obviously if it's all open source.
It's not. We are working on it because a bunch of the node services are pretty generic, so they can be used for other cases. It's, we're a corporate and these things take time, but it is our plan to open source a bunch of these services. We can talk about it after if you want, and we could see what we could work out together.
Okay, that's fantastic. That's great, Avital, and thank you. It was a real honor to host you. And
thank you for having me.
I'll record that because that's that talk was absolutely exceptional, and I hope we can continue later at 8. We'll join Clubhouse. I know you have the app, so
I do.
I will open the Warsaw.js room.